Hi friends, welcome back on our YouTube channel. In today's lecture of classical mechanics, we will discuss about center of mass frame of reference, and this frame of reference is also known as C frame. So today we will discuss about center of mass frame of reference or C frame. Now here we have a particle which is at point P1 and the mass of this particle is m1 and the position vector of this particle is r1. Here we have another particle which is at point P2 and the mass of this particle is m2 and the position vector of this particle is r2. So here we have a two particle system. Now the center of mass of this two particle system lie on a line which is joining these two particles, and the position vector of this center of mass is RCM. So the position vector of center of mass is RCM equal to m1 r1 plus m2 r2 upon m1 plus m2. For n particle system, RCM equal to m1 r1 plus m2 r2 plus mn rn divided by m1 plus m2 plus mn. So this is the position vector of a system of n particle, or RCM equal to sigma I equal to 1 to n mi ri divided by sigma I equal to 1 to n mi. Since the total mass of this two particle system is capital M, so sigma I equal to 1 to n mi equal to capital M, and this capital M is total mass of the system. So RCM equal to 1 upon m sigma I equal to 1 to n mi ri. A frame of reference carried by the center of mass of an isolated system of particles is called the center of mass frame of reference or C frame. Now RCM equal to 1 upon m sigma I equal to 1 to n mi ri. If RCM represents the position vector of center of mass in C frame, then RCM equal to 0. So this will be 0. Since RCM equal to 0, so the differential of this RCM, that is VCM, is equal to dRCM upon dt will be 0, and this VCM is the velocity of center of mass. Since momentum P equal to mv, so the momentum of center of mass P equal to m VCM equal to 0 because VCM is 0. Thus this frame of reference means C frame is also known as zero momentum frame because the momentum of center of mass is 0. So C frame is also known as zero momentum frame. Since in the absence of external force, C frame moves with constant velocity, so it is also called inertial frame. So C frame is also known as inertial frame. So here we end our session. In today's session we have discussed about center of mass frame of reference. So goodbye.